Hello everyone, welcome to NPTEL class. Here is chemistry detective to solve your chemistry class 11th NCERT problem 2.1 from your unit 2nd, that is structure of atom. Problem has two parts. In part first, we have to calculate number of electrons present in 1 mole of methane, and in part second we have to calculate number of photons of light with wavelength 400 picometer that provide 1 joule energy. Now idea is that for part first, idea is that methane is molecular. We will first calculate number of, we require two ideas. First, number of electrons present in its one molecule, and second, number of molecules present in its 1 mole. And idea is that 1 mole of methane will have 6.022 into 10 raised to power 23 molecules, and second idea is that in 1 molecule of methane we can count electrons. There is 1 atom of carbon, and for 1 atom of carbon there are 6 electrons. For 4 hydrogen atoms there will be 4 electrons. In total there will be 6 plus 4, 10 electrons in 1 molecule of methane, and we will multiply this 10 by Avogadro number. We will get number of molecules present in 1 gram of methane. Second part is based on quantum theory of radiation, or Planck's quantum theory of radiation. And in this theory, Planck suggested that radiation can be subdivided into discrete chunks, packets, bundles, and atoms or molecules can emit or absorb energy in these small chunks, packets, bundles, and smallest unit of energy which an atom can absorb or emit was named by Planck as quantum. And in case of light, instead of quantum we use photon, and energy of 1 photon is equal to h nu, but here h is Planck's constant, nu is frequency. Here nu is not, here frequency is not given, here wavelength is given. So we will express frequency in terms of wavelength, and thereafter solve the equation. We will solve equation E is equal to h c by lambda. But total energy emitted or absorbed will be equal to n number of quantas emitted or absorbed. That is, it will be the nth integral of quantum, or nth integral of energy of 1 photon, which is h nu. So I will start solving these two parts with these ideas. Number first part, 1 mole methane. 1 mole methane is equal to Avogadro number of molecules, Ne molecules, and 1 molecule of methane contains 10 electrons, because in 1 molecule of methane there is 1 carbon atom having 6 electrons, and 4 hydrogen atoms having 1 each, 4, that is 4 electrons. 6 plus 4 will be equal to 10 electrons. Now I can easily calculate number of electrons present in 1 mole methane. Number of electrons present in 1 mole methane will be equal to number of electrons present in its one molecule, which is 10, and total number of molecules, which is Avogadro number 6.022 into 10 to the power 23, and it will come equal to 6.022 into 10 to the power 24. Leaving this value, we can say that total number of electrons present in 1 mole of methane is 10 to the power 24. Now moving to next. Next is, in next part, wavelength is given equal to 400 picometer, 4000 picometer, and energy is also given 1 joule. With these two known parameters, I have to calculate number of photons of in radiation of wavelength 4000 picometer having energy equal to 1 joule. I will use Planck's idea that energy of one quantum or energy of one photon is equal to E is equal to h nu, and total energy emitted or absorbed by source is equal to energy of n photons या energy of n quanta. Now energy of one quantum or one photon is h nu. Energy of n quanta will be equal to, energy of n photons will be equal to E is equal to nh nu. Total energy emitted or absorbed is nth integral of h nu, and this n can take value only 1, 2, 3 integral value, not 0, not fractional, which is also proof of the fact that energy absorbed or emitted by atoms is quantized. It can take only fixed values equal to 1 h nu, 2 h nu, 3 h nu, and cannot take value in between these values. Now keeping in mind that frequency is not given, wavelength is given, I can express frequency in terms of wavelength. So exact equation that I will use here is E is equal to n h c by lambda, because we know frequency is equal to velocity of radiation divided by wavelength of radiation. Nu is equal to c by lambda. Now this equation has 5 parameters total: energy, wavelength, number of photons, Planck's constant, and velocity of light. Planck's constant and velocity of light are constant parameters. Lambda is given parameter. Energy is also given 1 joule. I have to solve this equation for n, and value of n, number of photons, will be equal to E. Number of photons will be equal to E into lambda divided by hc. I will substitute the values. Energy is 1 joule, lambda is 4000 nanometer, 4000 picometer, and 1 picometer is equal to 10 raised power minus 12 meter. I will express in SI units, 10 raised power minus 12 meter. Planck's constant is 6.626 into 10 to the power minus 34 joule second. Velocity of light or radiation is 3 into 10 to the power 8 meter per second. Now meter in numerator will get cancelled. Second and second inverse in denominator will get cancelled. Joule and joule will get cancelled. And on RHS side there is now no unit because number of photons has no units. And after solving n comes equal to, I have already evaluated this value, it comes equal to, in standard form या in scientific form it comes 2.0 into 10 to the power 16 photons or quantas. General word is quantum. In case of light, instead of quantum we use photon. So for quantas, photons in case of light. Now what is the information? The added information is that 1 gram of methane has 10 to the power 24 electrons in it. And second, 1 mole of methane has 10 to the power 24 electrons in it. And second information is that if we have a radiation of energy 1 joule, and if this radiation has wavelength equal to 4000 picometer, number of photons in this radiation, number of photons in this light are equal to 2 into 10 raised to the power 16. This is all for today. See you, class 11th students, see you on Monday, because Saturday is reserved for class 12th students, inshallah. Take good care of yourself, take care of your work and health. Allah Hafiz.